Hello, this is Marvin Glotfelty. I'm a hydrogeologist and driller from Arizona, bringing you another industry-related video from the National Groundwater Association. Today, I want to talk about string weight analysis in my book, The Art of Water Wells. This was actually presented as one of the appendices in that. But I wanted to go ahead and provide it as a video as well. I'm going to share my screen and show you some animations just to clarify this. The point here is when we add filter pack, we'll install a trimmy pipe and add our filter pack sand in a well. I've had drillers telling me that there was actually a downward force applied, and sometimes that when they had their casing and screen hung from their drawwork, so they had a weight indicator. They saw that the weight was going up and up and up as they were adding filter pack. And that kind of makes sense, that as you would add sand around a cylinder, it's downward as it fell through the fluid and settled into place, it might extend a downward force. And I have even had drillers tell me that in some scenarios that it might could even pull things in half or cause problems with the well itself. So I wanted to test this. And so many years ago, and this is back in about 2003, as I recall, my company decided to test this in a couple of actual wells we installed. So it turned out to be a little interesting experiment for us. So this is the scale that we got. We rented this scale. These you see in the upper right here, these two hydraulic scales and the casing of two different wells in sequence. We had a project to put in two wells in one of the municipalities in Arizona here. So we landed both of them on these scales, as you see, and that meant that the weight indicator on the drilling rig that you see in the upper left there could actually tell us the weight of the casing as we installed it and as we added different materials. So I'll show you these two different case studies of measuring the string weight as the well was being constructed. And it turns out that there was, in fact, an impact of adding these annular materials. So in the first well, this is a 1,750-foot deep well. It had a total of 460 feet of screen. That was louvered screen, 16-inch diameter in the upper part of the screened interval and 14-inch diameter in the lower part, with a telescoping diameter, as you see. And then you can see from the materials we had 812 mesh filter pack sand, a few cement seals and bentonite seals, fine sand at some to provide a transition sand at some locations, and then formation stabilizer, which is effectively pea ground. So as this well was being constructed, first we installed the well, measured it as it was being installed, and at the maximum, when it had been landed on these scales, it was 92,000 pounds. So that's the baseline. This is just without any annular material having been installed. When we added filter pack sand covering the lower screened interval, we saw that string weight increase from 92,000 up to 104,000. Then we swabbed a little bit we added bentonite on top of that. And the bentonite swells up and seemed to provide a little bit of a buoyancy effect. So it dropped from 104,000 now down to 100,000 pounds. So there we're seeing that installation of sand, installation of bentonite chips, the weight actually drops a little bit as those chips swell. They seem to provide a little bit of a buoyancy effect. We then added some more filter pack sand to cover the second screened interval. And in this second interval, the impact was much less. The weight stayed pretty close to 100,000 until we swabbed it in place. And as that filter pack sand then settled a little bit, we did have an increase from 100,000 up to 104,000. So now we are back up to 104,000 pounds, increased from the original, which was 92,000. So then we added some more annular materials, including our cement seal, and had a notable buoyancy effect there, where the string weight, as measured at the land surface, dropped down to 94,000 pounds. So then we completely developed and installed the well with a net change. So we had a drop all the way down to 63,000 pounds, and then a little bit back up to 65,000 pounds during the final formation stabilizer installation. So we have quite a change here. The net is 12,000 pound increase followed by a 27,000 pound decrease compared to that original string weight. Well, that may mean nothing. And keep in mind, all this is measured at the land surface. Because steel is ductile, it could be under tensile stress at some depth and not be measured at that stress at the land surface. So we're just measuring at one point. However, we have tens of thousands of pounds increase and decrease here. And so what's going on? Well, we don't, I can only tell you what we've measured, but there's certainly something going on. So if you were at the very limit of a casing string being able to support its own weight, or at the limit of the mast capacity of the rig, you would see changes. And that's something that is certainly of note. It does seem that as we go through the complete installation and development process, any stresses that are on the steel are being relieved. And that's important. That's good news, because I think that if you took steel and put it under a stress, a tensile stress, and kept it onto that for the life of the well, that would impact and probably create problems with the longevity of the steel. Just being under that stress, the metal fatigue may be different. So this is the first well. Then we immediately moved our scales and our driller over to the next well and put in a second well. So here's the second well, 5 different screened intervals, identified where there's good production zones in this well. It's a 1,500-foot well with 430 total feet of screen. And this is 16-inch from top to bottom. Again, louvered screen. It's 16-inch diameter with 3125 walled casing. So the filter pack is the same. The bentonite seal is pretty much the same design as you see. So when the well was first installed, the casing, it weighed a little less, being a shallower well of 77,000 pounds. And so when we installed the first lower part of the filter pack to cover the first 2 screened intervals from 1,500 up to 1,300 feet, we saw that the string weight, again, as with the first well, increased up to 90,000 pounds. And when we would swab that to settle the filter pack, an additional increase up to 94,000 pounds. So now we have this increased weight on measured at the land surface. So we added the upper part of the filter pack, and again, as before, after it settled the first portion up to 1,300 feet, the next portion, not so much of an impact, stayed pretty stable until then we swabbed a little bit, and then we had, once that upper sand settled a little more, we had an increase again. So as the sand settles during swabbing of it, that's what makes it settle, and that's what makes the string weight increase. So we then added our bentonite seal, which of course applied a buoyancy effect. So we had a decrease in that string weight from that, the weight dropped down to 73,000 pounds. And then with the formation stabilizer, we added that went up to 80,000 pounds. And then during development, a little bit of up and down. So the net result of this well was a 25,000 pound increase, followed by a 7,000 pound drop above. It dropped to where it was 7,000 above the original string weight. So pretty close to where we started, but a little bit high on this one. So from this, I'll unshare my screen here. A few things we can conclude. One is adding filter pack sand does increase the string weight by tens of thousands of pounds in some cases. And swabbing that filter pack to settle it further increases that string weight. We can also say that if we have multiple screened intervals, the uppermost filter pack intervals will have less impact than the lower one. And bentonite and cement annular steels both apply a buoyancy effect that seem to relieve these stresses. But it's interesting to note these things. And so it's a kind of thing that we should keep in mind as we design and operate and construct wells. Thank you.